Alright, now let's combine our current circuit laws, all the circuit laws with the series and parallel configuration in this practice problem. The first step to do in every problem is just mark out all the nodes. This is node A, and this is node B, this is node C. These are the three nodes. You can just check them out, and these will be the three nodes. Now, let's see if we can find some elements in series or parallel. The first thing to notice is these two 6 ohm resistances, they are connected between B and C, the same pair of nodes. So 6 ohm resistance is parallel with the 6 ohm resistance, and we can find the new overall resistance by this formula, which is 3 ohms. As you can clearly see, they are hard, so that is something to note, that whenever two same resistances are connected in parallel, the overall resistance decreases. Now, the second thing to do is, let's just draw the new circuit, and we can see that I'll just skip all of this. This is the same, but here there is the 15 ohm resistance, this one, and then there is our new 3 ohm resistance. Now, if I just skipped this entire portion because this is the same as before. I can see that these two are in series now because this is a node and it has only two resistances connected. So we can just combine them two, and we can say that the new resistance is 18 ohms. Now let's draw our entire circuit again. This is the 6 amp resistance. This is the 3 ohm resistance. Now the circuit comes out to be this. Now let me just clear this up and show the next step. Now we can clearly see that there are just two nodes and everything is in parallel now. So I'll just combine the resistances which are meaningless right now. I wouldn't call them meaningless, but for example, I wouldn't combine this 3 ohm resistance with this 9 ohm because there's this I3 involved, which is through the 3 ohm resistance. But I can combine this 9 ohm resistance with this 18 ohm resistance because they're in parallel. And I can combine this 4 amps current source with this 6 amp current source. So let's just draw our new circuit. One thing to keep in mind is that we cannot combine the dependent current source with this independent current source because they are two entirely different circuit elements, and the dependent sources should never be combined with any other dependent sources or independent sources, because the dependent sources, their values depend on every other element and they are completely different and disparate. This is something to note. Now after combination, this is what my circuit comes out to be, and I will now apply my current laws here. This was I3 and this was V. So there are just two nodes. The first thing I would do, because this is kind of like a single node pair circuit, so I would apply KCL at node A. So let's just apply KCL at node A. Kirchhoff's current law. There's 2 amps entering node A. There is some current leaving, which is I6, the current through the 6 ohm resistance, so minus I6. There's I3 leaving, so minus I3, and there's 0.9 I3 coming into the node, so it is 0.9 I3. This is equal to 0. So let's just simplify this. So this comes out to be minus 0.1 I3 is equal to 0. Now there are two unknowns, but it's just one equation, so we would use the same concept as we used in our single node pair circuit. We'll combine these two currents through our voltage. So the voltage across the 6 ohm resistance is VAB. The voltage across 3 ohm resistance is also VAB. So I6 can be written as VAB, the voltage across the node A and node B, divided by 6. I3 can be written as VAB divided by 3, and then I can substitute these two into this above equation, and I can write plus 2 minus V over 6 minus 0.1 V over 3, and now I can clearly solve this equation for V and I can find the answer. So this is how you can combine elements, and you can utilize your current laws or voltage laws into the simplified circuit to find voltages or currents. So I hope you understood.